Alright, coder. Today we're going to go over products of array discluding self. This is the penultimate problem in this table of arrays and hashing. This is a medium problem. Let's get right into it. Given an integer array nums, return an array output where output I is the product of all the elements of nums except I. Each product is guaranteed to fit into a 32-bit integer. And then it says follow-up, could you solve it in O of n time without using the division operation? But spoiler alert, we're going to actually skip the brute force solution and jump right into the optimal O of n time solution. Let's look at the first example. It says nums equals 1, 2, 4, and 6. The output should be 48, 24, 12, and 8 in the second example. There are 5 elements, -1, 0, 1, 2, 3, where the output should be 0, -6, 0, 0, 0. Constraints are 2 is less than or equal to the nums.length, so the length of the array will be less than 1,000, no more than 2, so it'll never be an empty array. That's nice, thank you. And then the elements will range from between -20 to +20. Sick. Let's get started. Alright, first things first, we're going to need the size of the array so we can use that to initialize our output. So let's make our output. It's going to be a list of integers, call it result, and it's going to be same size as the array, and it's going to just initialize with all ones because we're going to just neutralize everything so that we go multiplying these values and accumulating them in this output array neutrally. So we're going to need a left product and a right product. Int I equals 0, I less than the end of the array, plus I. Start our index at 0. Thinking. Alright, we're going to set the value of result to 1, to first our left product. And left product is going to be where we store the accumulating product as we go multiplying. So we're going to say left product times equals nums I. So as the iterator moves along, it's going to keep on grabbing everything from our input array and multiplying it over and over again. So first one doesn't quite change, but then left product times equals 2. Now we're at index 2. So we're going to set that to left product, which is now 2. Then it's 2 times 4 equals 8. Index moves up to 3. Then left product at result at index 3 equals left product, which is 8. It is going to go one more time and say times 6 equals 48. But at this point, we're out of the array, so it's going to end the loop, and we're going to move on, having changed result I to 1128. Now we set our loop at the end of the array by saying index I equals n-1, the size of the index minus 1. And while I is greater than or equal to 0, minus I, and then set result I to multiply the value of right product. Because we've already started with an accumulated value, we want to keep that going. Right product is 1, nums I is 6, 1 times 6 equals 6. So we're going to say right product, and we're going to go minus, right? We're going to go to index 3, 6 times 2 is 12. Now right product times equals 4, so that's 6 times 4 equals 24. So now we take, there's the correction. Now we're at index 1. Result I at index 1 is 1 times 24, so that's 24. And then right product times equals nums at index 1, which is 2, so 24 times 2 is 48. Now we go down to index 0, 1 times 48 equals 48. And now we do times 1, which is 48, but we would be out of the index anyway, so that's it. That's our final result. We can return this and satisfy the hunger of the beast. Submit it. And another one bites the dust. Check that off the list. I already did. Party on, Wayne.